Hey guys, this is Sister Kelly, and I'm sorry I couldn't be there today, but we're going to try this to cover section 2.4 of your text, which is chemical reactions and enzymes. You should have gotten the guided notes from your substitute teacher. Treat him or her right, please. We're going to try to do this in 2 videos. So the first video, this one, is going to cover chemical reactions, mainly focusing right here on the types. We'll talk briefly about reactants and products, but it'll be a review. That was on the last test, may be on next week's test. It'd be a good idea. The second video, assuming this one works, will cover enzymes, how they work and function. That one's going to be a little bit longer. This is the test drive. Okay? So let's go ahead. We'll start with chemical reactions. A chemical reaction, as you can see, is any process that changes or transforms one set of chemicals into another. So notice, remember, the reaction's the arrow. Anything that goes into the reaction, so all this stuff over here on the left, that's the reactants. Reactants go in, and the stuff that comes out, or the stuff that is produced, are the products. So in this reaction, methane and oxygen go in. They're the reactants. Carbon dioxide and water are the products. They come out. Okay? Now, this is the new stuff. There's 2 types of reactions: energy absorbing and energy releasing. So either energy in or energy out. Let's look at an energy releasing reaction first. Energy releasing starts off with high energy, okay? And then notice the products are low energy. We've gone down. So the energy has been released somewhere. It might be light, it might be heat, maybe it got stored in a different molecule, but either way, it is gone. I think you can figure out what's going to happen next. The second reaction, energy absorbing is energy in. So this one's the opposite. We start off low. The products are high. So some type of energy has entered in. A great example of this is photosynthesis. Okay, I ran out of room there. Photosynthesis, the energy that comes in is light. So the light energy is stored in sugar, a very high energy product. Okay? So energy absorbing, energy comes in. Now if you look at your notes, you'll see something looks a lot like this. This is question 3. The question in your note says, which one is energy absorbing? Which one's energy releasing? I'm going to let you think about that for just a few moments. You might want to pause the video. Try to see if you can figure it out on your own. Think. And again, guys, best place to look is, are we going low to high, or are we going high to low? If we're going from low up, then we've got to be storing energy. This one is energy absorbing, which means here we're losing it. We're going from high to low, we're losing it. This one is energy releasing. Were you right? I hope so. I think so. I have faith. You were dead on right. Okay, last little bit of information here. The energy needed to get a reaction started is called its activation energy. I hope y'all can read my handwriting. This is harder than the whiteboard. Activation energy is always this peak, and it doesn't matter if it's energy absorbing or energy releasing. There's always some peak of energy required to get from reactants to products. Think of it, a good way to think of this, gasoline, right? Gasoline releases a ton of energy if you set it on fire. The match required to light gasoline represents the activation energy. Once I activate it, then energy is released. But I've got to put a little bit of energy in first. I got to kind of like pay a tax. Just a little bit of energy to get over the hill to activate the whole reaction. So that's the price of doing a chemical reaction. All right. And oh, look, they're labeled here. Activation energy, activation energy. Okay, the price of doing the reaction. All right, that's the first part done. Look at all the lovely check marks. I'm going to pause here and make sure this works, and then we're going to go on. So the second video will cover enzymes. See you there.